Good morning, everybody. Welcome back to the GSE conference and welcome especially to the security stream. And we've got a full agenda today, so there's lots of security sessions running throughout the day, as well as other streams, of course. But it's our last day of the conference. So I can't believe we were just saying earlier on in our little WhatsApp chat group for GSE. I can't believe it's like today is the last day. Couple of things just to make you aware of. So today is Armistice Day, and I think in the US it's called Veterans Day. And at 11 a.m. today, we will stop for 2 minutes just to do like our 2 minute silence, as we always do every year in the UK, to remember basically remember those who gave their lives in service to their country since 1914. So we will stop the presentation that's scheduled for 10:30 for that 2 minute silence at 11 o'clock, just to make you aware of that. So yeah, this is session 1BE, and it gives me great pleasure to welcome Jacob Balhar, live from Prague. So welcome, Jacob. I think it's your first time on the security stream, isn't it?
Here in the GSC, yeah, it's the first time for me.
Yes. So Jacob is working for Broadcom, and he's going to talk to us today about DevSecOps and the shift left security strategy within Zowe. So Jacob did say, he did mention this earlier on, he will be taking questions at the end, but equally, if you just pop them in the chat as as they come to mind, and if he sees them, he'll read them out, and if not, he'll save them up until the end. So Jacob, welcome to GSE, and over to you, sir. Thank you very much.
Okay, thank you very much, and welcome everything who joined today's speech. Apart from being here in terms of the Broadcom representative, I'm also the representative of a Zowe as the Zowe chair. So ultimately, wherever we fail as a Zowe, it's my responsibility. So if you see anything that you think we can do better based on this or based on your knowledge of Zowe, just let me know and I will try to do something about it. For those of you who are joining the GSE UK for the first time, there is a charity raffle for the GSE UK conference. So if you are feeling inclined to donate and help appreciate the National Lifeboat Institution or Guide Dogs for the Blind, here is the guidelines on how you can do it and how you can help via the GuideShare Europe. And now for the speech itself. So it will mainly have 3 parts. First, I'll be covering a bit around what is Zowe and the main areas like the cybersecurity, DevSecOps, and executive order to make sure that we are on the same page. And then I will talk about how do we do the things in the Zowe, what is the current status of the work that we do. And then in the end, I will also, if I have a bit of time, touch what is next, where we are going, what are our initiatives around security for the future. So let's start with what is Zowe. Zowe is the first ever mainframe open source project within the ZOS world, at least. It's hosted by the Linux Foundation, and it's part of the Open Mainframe project. Everything that's part of the Zowe is released either under Eclipse public license, it's a copyleft license that requires the contributing back, or for the pieces that we expect the customers or users to use directly in their code base, we have pieces that are licensed under Apache public license. The project itself was announced at Share in 2018, and the GA happened February 2019, so basically 2 years ago. Next February, we are going GA with V2, but that's for another topic, and I'm not gonna touch much more. As for the initial contributors, the project started via a large contribution from IBM, originally CA, now Broadcom, and Rocket Software that donated the key components that I will explain a bit on in a few minutes. What it aimed to offer us is the open, modern, and standardized platform. There are 2 goals. One of them are, of course, the users for whom it's easier to access the mainframe without previous knowledge. The second are extenders and the companies that want to provide additional functionality using the ZOS and mainframe tooling. As we are going to talk about the security, it's important to mention how we are structured on like the personal level. So the Open Mainframe project is an umbrella organization we are part of. The two main bodies or governing bodies is the Technical Steering Committee. This is the actual governing body where the members of the squad meet and agree on guidelines, principles, and policies that will be then applying to the whole Zowe. I'm the head of this Technical Steering Committee as of now, which means that I'm responsible. Apart from that, we used to have Zowe Leadership Committee. This was gradually transferred into the Technical Steering Committee, but we still retain Zowe Advisory Council, which are the people from business side of the companies that are helping us move in the right direction. For anyone present, it's possible to join. There is public meetings, and we want to hear the voice of as many users and extenders as we can. Apart from that, we have the squads. Basically, a squad is a group of people that is responsible for one or more components and that follows the guidelines and principles stated by the Technical Steering Committee and also have a representative there. On top of that, they can also provide their own governance as long as it's within the framework provided by Technical Steering Committee, Open Mainframe Project, and Linux Foundation. So a bit around the internal structure from the perspective of the components and what is actually part of it. We are mainly working with 4 user personas. It's Ravi, that's a DevOps engineer. It's Michelle, it's app development that's developing new applications. It's Tyler, sys administrator, new gen that's relatively new to mainframe, but wants to be useful addition there, and Isabel, which is an operator of the mainframe. As for the Zowe itself, there are 3 key parts, let's say. One of them is a set of microservices that's running on the ZOS, usually running on the ZOS, with the API mediation layer that simplifies access to them and unifies the identity and access management. Then there are the SDKs that allows the extenders to develop extensions to the Zowe itself and use their own application. Then there is a part that's running in the developer's computers, so the client side, and there we have the Zowe CLI, which allows you to communicate with the mainframe via the CLI tool and the Explorer in the Visual Studio Code as of now. We are also looking for extension to other non-Visual Studio Code integrating development environments. Apart from that, for the users that are more just integrating with the mainframe or interacting with the mainframe, but not developing against it, we also have Incubator, so a mobile app that allows some access to the tooling and the application framework that provides a wide variety of the tooling that the users can use in the virtual desktop. So these are the components and modules that are taking part in Zowe as such. The next thing that I will be talking about is the cybersecurity to make sure that we are on the same side and that we understand similarly what is important and therefore later on why we are doing the things that we are doing. So cybersecurity in general is a set of tools and practices to guarantee the confidentiality, integrity, and availability. As we are in the security track, I believe that you've heard already about this so far. Confidentiality basically means that once you receive some data, they will stay in your space and it's not gonna get away without your knowledge. Integrity means that the data won't get corrupted, you won't get the malicious data inside. When you have somewhere some data, they will be complete as much as possible. And for availability, well, most of you have already seen some DDoS attack or been a target of it. So the availability is around making sure that the systems stay up as much as possible, given the reasonable budget constraints. So what are the areas of interest within the cybersecurity? So the main ones that we will be talking about here are the identity and access management. It's very important to make sure that we know who is accessing the resources and how are they allowed to do so. Second one is the cryptography. This is the baseline to make sure that only the people that should have access to the data have access to the data, meaning that even if somebody steals them in transit or steals them from the disks, they won't get anything useful without having the right keys and having the right tools. Next are the privacy engineering. This is, I would say that it's still more of an issue within Europe with the GDPR. So there are more areas around privacy that are pushed on here in Europe than e.g. in US, for example. Then I'm talking here about cybersecurity measurements, I'm talking more around the operational topics. So how do you figure out what's going on in the system? How do you verify that you understand well enough what's going on and that you can therefore identify and prevent potentially risky behaviors as well as the malicious players within the ecosystem. Last one is the transported platforms and networks, but as we are mainly still involved within the Zowe platform, I guess that we can agree that it's perceived as the trustworthy platform so far, and that the network operators usually have tens of years of experience, and so usually do quite a good job there. Another topic that's very important and relevant to this, we will also touch it later on in the executive order, is the zero trust architecture. Basically, it states that you always need to be more diligent and you always need to trust less. So wherever you are talking about any type of confidential data, data that are relevant for the business or just the accessing of resources, you need to be very careful in how you do that. Like earlier in the recent years or like recent decades, maybe the main way of defense for the enterprises was a static defense with the network-based perimeter, where the assumption was that we will do all we can to prevent the attacker coming in. But with, and it kind of worked. But with the bring your own device, remote users, cloud-based assets, this is not really viable anymore, at least not that much. So we need to figure out other toolings and other approaches, and the zero trust architecture is one of these approaches, where based on the asset ownership, you always verify whether the users have the correct access rights, where the data are encrypted at rest, data are encrypted in transport, and ideally in memory as well. The zero trust architectures focus on the protecting of the resources. It doesn't matter where they actually reside, it just matters that they are important. Networks are always unsecure, at least to some extent. So there are a few more topics that are related to this. The first one is the access and monitoring. This is related mainly to the zero trust architectures, but in general to the cybersecurity at all. So first, all the data sources and the computing resources are considered resources. So it's something that you need to protect and you need to verify and monitor access to. All the communication needs to be secured regardless of the work location. So regardless of whether you are in your office on the same physical network or whether you are somewhere in the middle of the Africa, it needs to be secured more or less in the same way. The access to the individual resources is granted on a per session basis. This means that you limit quite a lot for how long and in what way the user, employee, customer access the specific resource, and that you monitor diligently what's happening with it to find out potentially risky patterns in the usage. Part of this is also the monitoring and measuring of the integrity and security posture of the assets, where you may do some exercises, as we will see later in the DevSecOps sections. But also it's about the process that you use to build and secure the environments and everything. An important part around the safety and security of the resources within the company is the introduction of the dynamic policies. What do I mean by the dynamic policy here? Means that you need to take into account the context of the action of the individual. So if it's an individual that in general does have access to a specific resource, the static approach would mean that this person always have the access and there is no additional challenges. The dynamic policies introduces the possibility to take into account how the user behaves, what are the patterns of the usage of this and the other service, and based on this require further authentication or an authorization, or even you can just reject the access to the service for the time being. Part of these dynamic policies that's necessary to be able to actually do this is the collection of the information. The enterprise need to be able to collect lots of information and analyze them around the state of the assets and infrastructure and communications. With respect to privacy, it should also do this to the extent that's relevant. So not just taking any data that's possible, but keeping to the ones that are actually helpful in improving the posture. So let's move on to the DevSecOps itself. So DevSecOps is a follow-up to the DevOps. I believe that most of you are already familiar with the DevOps paradigm, but I will talk a bit about it to explain why the sec is important and how it got there. So the DevOps is an approach that tries to minimize the risk of deployment of the new functionality by making sure that it's deployed often, is deployed in a minimal chunk, and that it's always monitored. How did we get there? We've built the teams that are responsible for operating their own solutions. So basically it's a group of developers that is responsible for making sure that the applications operates as expected. That also are responsible for the adoption, for planning for the future features and functionalities, and basically the whole process around a specific product or service or application. The issue with the sec in this DevOps paradigm is that most often it used to be retrofitting security controls that were happening afterwards. In theory, it could work if you have enough time to actually really go through the product, but with hundreds of releases a day, like the people are not able to follow. So that's where the sec is getting in. It's the integration that brings the tools and the people in the teams so that they are aware of potential security risks, so that they are aware of the tools that the enterprise have for the automated analysis, verification, and even attack potentially. And they are making sure that together what they built is not just developed well, not just operated well, but also secured from the business perspective. So now I will go a bit through the principles of the DevSecOps. If you would want to learn more, there is a devsecops.org webpage, and not just the principles, but also lots of other resources are available there. But let's go to the principles and what does it mean for us as the engineers also within Zowe. So the first one is leaning in over always saying no. The idea here is that lots of the time the security just states, okay, you shouldn't do this. No, this is not how it's done. The change here is that instead they should change this approach from no, you shouldn't do it to hey, maybe you could try using this as a part of your pipeline and it will help you with figuring out how to prevent these problems, instead of them stating, okay, you can't deploy this at the moment. Next one is the data and the security science over fear, uncertainty, and doubt. This is more around the psychological safety. The teams should build, or the security people should build their recommendation based on the data and science, and as such share it with the other teams that will depend on them. Open contribution and collaboration over security-only requirements. This is very relevant for us as we are open source, so we do contribute in general in open. But even within the enterprise, it's important to build the communities of the people that are sharing the information and making sure that everyone is at the speed in what's requested. Next one is around consumable security services with APIs. That's what I was already talking about a bit. We are looking for the help from the security in terms of APIs we can introduce in our pipelines to make sure that the produced software that passed the pipelines is safe. It's rather difficult to introduce like human or non-automated controls within this because it always delays by quite reasonably and prolongs the feedback loop. And the last on this page is the business-driven security scores over rubber stamp security. Like getting some stamp that states your software is safe, that doesn't matter unless it's also safe in the production and while delivering the business value. So these are the first 5. Then there are the remaining 4. So it kind of sounds a bit contradictory with the red and blue team exploit testing over relying on scans and theoretical vulnerabilities. But we should use and rely on scans. But on top of that, there is more what we can do, e.g. Splitting the DevOps or DevSecOps team in 2 smaller teams where one is defending the solution while the other one is attacking it. And this can tell you a lot about the threats that your solution is well equipped to handle and the issues that it's not. Next one is the proactive security monitoring. I was always already talking about it. Like in this age, operational monitoring of everything 24/7 is just something that needs to be done in order to make sure that the customers are safe and the systems behave as expected. The last 2 is the shared threat intelligence. This is more on the enterprise level than team itself, but within the teams it could be as well. You need to share intelligence across the team, across your value streams and businesses, and also between the businesses to make sure that together we build the landscape that's safe and that has as limited amount of risks as possible. And the last one, unless it's operated well, the fact that you have some clipboards and checklists just doesn't matter. The operation is where it matters ultimately. So the next one is to get a bit into the executive order. I'm rather sure that most of you have heard about it. I'm talking about the executive order of the Joe Biden, but ultimately there are other very similar either laws or initiatives across the world. So this is just an example that I've selected. Most of them are sharing lots in common. So the order itself was the reaction to the barrage of the cyber attacks on the different parts of the industry, and it was across the board within the physical industries like the hospitals, energy. Also, it was in banking and IT supply chains, and was touching other industries as well. What it does is it puts some requirements on the government institutions as well as their suppliers. So even if you are not a government institution of US, but you are providing some solution that somebody then uses and sells to the government, it's gonna touch you. So the first area here is the sharing of the threat information. So this is a requirement for the Federal Information System and service providers, including cloud, so e.g. Amazon, Microsoft, Google, and others. IBM, of course, IBM Cloud with the hybrid Z solutions. There are some specified timelines that will be adapted and reflected and overseen by one of the administrative offices within the US, and the zero trust architecture I was talking about before is required by all of the systems, all of the providers, and so on. Second area the executive order is talking about is the software supply chain security. There are few areas that are around the people and few around proving that it's the case. So you need to audit the trust and prove that what you are stating in the other areas is valid. You need to make sure that you use the multi-factor authentication across the whole process to limit the amount of risks and problems that it can introduce. E.g., I'm not sure if you've already heard, but in the last weeks, there were 2 or 3 successful attacks on NPM where the credential of one of the authors were stolen and problematic version of the software was released, and it caused quite some amount of problems in the last weeks. You need to encrypt more or less everything at rest and at transit. It doesn't require in-memory encryption, though expect that this is just gonna happen within the time. And apart from that, it asks for the industry to provide the automated tools to demonstrate and verify the conformance. As we will see, some of them are already available and to some extent used, but I expect there will be more coming in the future. So the last thing it's talking about is the security development practices. Here, the executive order asks for the automated tooling for scans and included summary of these scans somewhere that the people can access it. It expects all the projects that are used anywhere to be able to create on request the artifacts. It expects that everybody will have the software bill of materials provision. Software bill of materials is as with the bill of materials for the standard factory release, just going through everything that's part of the release, basically file by file, explaining what it is about and why it's there. One of the formats that's gradually gaining traction is SPDX. It's a format that's been created and polished over the years by the Linux Foundation, which is also a format we use within Zowe. Apart from that, there is a requirements towards the vulnerability disclosure and around the conformity with secure development practices. So making sure that everybody develops in a safe way. And now finally to the Zowe itself. So where does we stand as a Zowe within this DevSecOps context, and how exactly does it apply to us? So for the rest of this presentation, I will be talking about 3 areas. First of them is the security in policies. This is around how do we make sure that everybody across the Zowe knows what they need to do, and so we can prove it also to anyone who asks. Second is the secure development. So what are the tools, approaches, and things that we do to make sure that the development of Zowe is secure and we don't let any malicious code or any malicious player inside. And the third one is the secure operations. Secure operations is around how does the Zowe helps with the security when being run in operation in the platform of the users. So let's go for the policy. Let's go for the policies first. So there are 4 main resources of the security in policies across the Zowe. We've got the principles that cover and contain the security as one of our core guiding principles. We have some security requirements coming from Linux Foundation. An example of such requirements is the requirement for the software bill of materials. And we have also some security requirements coming from Open Mainframe project, e.g. in the form of Golden Core Infrastructure Badge. For those of you who don't know, the Core Infrastructure Initiative is originally the initiative for making sure that the open source development is safer and done in a better way. And now it's part of the Open Software Security Foundation. Apart from that, we also have some security requirements in our best practices, as we will see in a few minutes. So let's start with the principles. So from the top, we claim that we will follow that, so it does not compromise on the mainframe security standards. We consider mainframe security standards to be quite well and quite strong. The principle itself is that the security is paramount, and we commit to secure development practices. We regularly perform the vulnerability testing of the Zowe project source code. and also the third party libraries we use. And when we found something, we fix it and notify the users of what happened and how they can prevent an issue for themselves. So this is for principles. For the Linux Foundation requirements, there are actually 4 of them that we need to follow. The first of them is the production of the software bill of materials. I will later on show how exactly it looks in our case. We are providing the TPSRs, third-party statements requirements. Again, we provide a list of the third-party components that we use to build with the proper licenses and verification that our usage is correct. Apart from that, we do regular static analysis of all the pieces involved in Zowe, as well as the dynamic analysis across releases. And again, I will go into more details when I will get to the secure development. This is just what is required from us. From the Open Mainframe project requirements, there are basically 2 things that are required. One of them is the secure build environment, so making sure that only the relevant personnel has access to the build, and so that when we produce and release a version and allow the users to download it, it's gonna be safe, at least as safe as we can. Apart from that, we were asked by the Open Mainframe project to get the Core Infrastructure Initiative badge, originally regular. As for this year, they are asking us also to deliver on the silver and gold. So let's start with and the last one here is the best practices. So best practices live within a community repository under the technical steering committee. There are 7 covered areas around what types of analysis we need to do on the squad level and on the whole Zowe level, some basics around our web page and information that we need to provide in documentation. How do we approach change control, version control system and its usage? How and that we require the multi-factor authentication. What standards of quality do we expect from all the developers, including the code convention, automated testing, coverage of the tests, and so on? What types of reporting we are looking for across the Zowe, and of course the security itself, like what are the security requirements that we put on Zowe itself. So the next topic I will discuss is the secure operation. So what are the features and functionalities that Zowe offers with respect to the operations, and how does it help? So first of them is that all the components within Zowe are engaged in the single sign-on support. It's interactive as well as available via REST APIs, meaning that the user doesn't have to keep track of multiple usernames and passwords for each of the services that are part of it. Of course, Zowe does support the relevant standards with respect to the HTTP transfer. We use the TLS 1.2. We have support for TLS 1.3, but we are still testing to make sure that it works properly in all the scenarios. We also support ATTLS for the ZOS deployments. To make sure that we are safe within this area, we do regularly update the set of ciphers to make sure that the ones that are weak are not anymore supported on our side. We require, or we provide the multi-factor authentication support. We provide it to all the Zowe components, but we provide just some integration with just some of the solutions. There is still work that can be done in future on making sure that we support more different approaches to the MFA than we do now. Apart from that, we also, for the mainly non-human actors, provide the support for the authentication via the public key infrastructure. And we do support it also for the users, but I would say that it's not so common for the users to authenticate via the certificates, sadly. Apart from that, the SAF-based access and RBAC. So I expect that most of you are well aware of the ESMs available within the ZOS space. So we do test and cover the SAF-based access via the RACF, Top Secret, and ACF2. We verify this for all the Zowe components, and we are never trying to go around it. We just depend on it quite heavily in Zowe. Apart from that, for the APML and application framework, we support some amount of role-based access. For APML, we have some REST APIs that allows you for the extenders to integrate with the RBAC based on stuff without actually having to go there. And the application framework supports and does this on their own, actually, in the API calls and within the virtual desktop you've seen earlier. So, and the last one and the most important one, at least from my point, with respect to how we develop, so we use the secure development. So we all make mistakes. We will make some that are relevant for the security of the software we build. We want to improve and make sure that we don't repeat the same mistake. We need to feel safe while doing so. We take the ownership for the processes, as this is what we can control. We learn from outcomes regardless of what they look like. It's a mantra of anonymous programmer that we are trying to live by as a Zowe. In a way, it's been inspired by the litany against fear from Dune, so it's kind of a similar one. And what does it mean for different groups of people across the Zowe? For the leaders, we need to make sure that the people we lead are okay if the outcome isn't okay, as long as they are responsible for the process. Because we are living in the uncertain times, we are living in some amount of unpredictability in everything we do. And so occasionally we will fail, and we know this, and it sucks, but that's the way life goes. But what we need to do is to learn and to improve our processes to make sure that with each failure we are getting better and less prone to such failures for the future. But it's not possible unless the people, the engineers that work with us, are feeling safe in bringing to us the problems that they are finding. Second part of this responsibility is to build a psychologically safe environment in which everyone feels safe to raise the voice. It's partially about the diversity and inclusiveness for everyone, but even if you have just a homogeneous group of people, it quite often is difficult for them to raise their voice if they feel that that it's just wrong to make mistakes. And we need to make sure that this is not the case and that they are fine with voicing their concerns. From the engineer's point of view, there are some responsibilities that we expect them to follow. We expect them to share the potential issues and faults with the colleagues, even if they are not certain, 100% certain, if they are only like, this looks like I'm possibly wrong, maybe I should share it. It's just the better way than finding it later on in production. We expect them to be very transparent and honest about it, and we expect them either as a persons or as a teams to actively look for the tools that will help them to uncover more mistakes. We also make sure that they feel responsible, but also empowered to adapt the processes that they are using to create the software, to make sure that they're automated, that they are working well, and that they are gradually producing better and better software. The last group I'll be talking here are the distributed engineers. I would say that all the engineers are distributed now, but it's important to mention, because working with the distributed systems is a bit different, as we know that some pieces of the systems will fail. And we are kind of responsible in figuring out how to make sure that even if some pieces of the system fails, the system still will deliver the results. To do so, we are building the environments to verify such situation in the near production or production environments, ideally without distributing the users and the business. The main goal here is to understand the system better and make sure that it's more resilient over the time. There are two areas within the secure development where we are touching it. First of them is the integration in the process of the development. The second is the integration of the continuous integration and continuous delivery pipelines. These are basically the automated pipelines that are being run on every commit, on every release, that are giving us the confidence that what we are delivering is okay. So within the process, there are three main tools that we are depending upon. One of them is we are doing regular retrospectives on every release around what went wrong. We are doing now the retrospective on the security issues and security bugs that were found. And we are doing retrospectives on planning as well. So we are heavily involved in making sure that we learn from our mistakes and from the things we've done and get better every time. Apart from that, we have the weekly security meetings where representatives of each squad meet and discuss where we are, what are the next steps, what we need to do, and share the insights and knowledge that they gained within their squads, within their daily operations. And the last one is that we are trying to build an organization that's actively learning and actively experimenting with new approaches and doing so fearlessly without the risk of being attacked by anyone. Within the CI/CD integrations, there are two things. First of all, we have all of our development pipelines either on Jenkins or GitHub Actions. We are more or less moving to the GitHub Actions, as it simplifies sharing of the knowledge across all the teams. Part of it is that one system squad mainly, but also others are building common actions that help understand the status of the repositories, help filter some common issues that we already know about, and therefore allows us to improve the product over the time. The next area I will cover is the CI batch, Core Infrastructure Initiative batch I was already talking about. So we do follow the regular one. So here I will be stating what are the areas that we are already following and how do we follow them. So for the automated testing, we expect all the squads to provide a unit test suite that's being run at least nightly, usually on every commit to the master branch or the version branch. We do have the automated and reproducible build for each of the components as well as for Zowe as such. So if you have the same source code, you are able to reproduce bit by bit the same results. We are actively looking for and fix the warnings found in the code while compiling or running the applications. As I already said, we have the security work group where the specialist means, and this means that we are certain that we have at least one security specialist on every team, every squad that we have. We do provide the information about the security vulnerability fixes in release notes, but this is only for the issues that we ourselves found. So I believe that we have just one so far. It's not for the third-party dependencies. That's a different one, and we will be publishing more on it early. There is a known reporting process on how anyone can let us know that they found an issue. It's in every repository under the security policy. There is a mailing list that only the security work group have access to, and they are following in and taking account in what's going on. That's the private way to let us know of an issue. So far, anything we got involved in, we did respond in less than 14 days, which is also what we need to do. And for the vulnerabilities that were at least medium, we fixed them in 60 days and make sure that they are available within the next release of the Zowe. There are some requirements on the secure delivery. We need to be very careful for the non-public arrangements leakage. We are using tools that are available via GitHub, some via Jenkins to make sure that this is not the case for us. We deliver all the created artifacts via the HTTPS, so with the valid certificates, so you can verify that it's coming from where it should come, and we provide a cryptographic hash, so you can verify that what you got is what we expected you to get, actually. So within the cryptography, we use just the public protocols and algorithms. We don't re-implement them. We depend on the free licensed open source software here, so you can verify yourselves. We are never using broken or weak cryptographic algorithms, and we are making sure that it's not the case on basically, I would say, the monthly basis. We are supporting all the solution, all the parts, all the components for secrecy, for key agreement protocols, and we use the cryptographically secure random generators. As for the requirements on analysis, there are some requirements around static and dynamic analysis. For both, we use at least one tool on every release. For static, we also require more or less on every commit to run the full set. And we are fixing the issues that we found there. So now I will show how does the different pieces and tools that we are using actually look like. So the first one is the software bill of materials. Basically, it's either downloadable as the SPDX, or it's also visible here as the HTML that's part of our documentation. So on the docs, Zowe docs site, you can go through all the pieces that are part of our released Pax file and see how did it get there, how it was built, what's the source location, and what it is about, basically. Apart from that, we provide the TPSRs. So here we are stating all the components that we are using across the whole software. And you can verify yourself that the licenses were flowed, that there is always a link to the correct places, and you can also see in which of our components they were used. I think we are also providing them in a format that's possible to understand and transfer automatically. So if you have some of your lists of potential risks or problems, you can verify automatically. The next part in this around the delivery is the fingerprinting. So for each of the resource that we provide, for each of the deliverable that we provide, we do provide also the fingerprint, so you can verify cryptographically that what you expected is what we expected you will get. You can see an example of how it look like. And again, there are tools that will verify this for you. You don't have to do it manually. So as for the APIs and the tools I was talking about in DevSecOps that the teams can integrate with, we have a pretty wide amount of them that we are using already. We use some of these tools only on a per release basis so far. We are looking to integrate them more often, but for now, some of them are on per release basis, and some other are happening either nightly or on every commit to the main branch slash the branch from which we release. There are different paradigms we use across the Zowe. So for the per release scans, we mainly depend on the Snake and Black Duck for letting us know around the vulnerability dependencies. We use the ACS to understand whether we have any issue in our C library and C framework in ZSS. We use Upscan for the dynamic scanning, so against actually running Zowe, and then OWASP, Polaris, and Coverity to understand more about potential security issues we have in our code. As for each of the squads, they are running either per PR or nightly the Sonar Cloud scans. So Sonar Cloud gives us information around unit testing and quality control, CodeQL. CodeQL is important because it's relatively easy to integrate new checks and functionality and share it across all the repositories within GitHub. Dependable and NPM audit to be early warned around any potential issues within the dependencies that these tools can find. It's not perfect, but it helps. So for the Sonar Cloud, for those of you who doesn't know it, so it's mainly a static analysis tool. We use it across the whole Zowe. On the right side, you can see how it looks. So first, these are public. So if you want, you can just go there and see what is the stage of the whole Zowe, where we are moving for each of the repository that's under our organization. An example here is the Zowe API mediation layer, which is one of the key components of the security across Zowe, where we have above 80% of coverage. We have some code smells, security hotspots, and vulnerabilities, but the security hotspots are only in the parts that are never shipped to the customer. So we can kind of live with that for now. Then we have the CodeQL. It's again static analysis. It's integrated well in the GitHub. It's also a GitHub action that's easy to run. And here, again, we can see some examples of the potential issues it found. We can based on this, either decide to keep them, some of them are closed because they are irrelevant for the customers and for us as well, or we really go and fix them and see what's changing here. Then the important tool that we use is Black Duck. Sadly, this is not fully public. This is running on premise of the enterprises that are cooperating, and they are helping us by delivering the results from the Black Duck. And this is mainly around the vulnerabilities within the dependencies. So it covers the whole packs that we deliver and find out all the known security vulnerabilities and make sure to notify us so we can fix them as early as possible, latest by the next release. Apart from that, we are also using SNCC. This is a tool provided to us by Linux Foundation. So it's also known as LFX Security. There again, this is focusing mainly, I would say, on the issues in the dependencies. Why we have such a high amount of the issues is because it keeps information from the archived repositories. So it's not fully representative. You need to go to the specific repo to see what's their status. The bonus for this is that it's totally public, so you can go there yourself and verify what's our status if you want to. So as we have a few more minutes, I will quickly speak about where we go. So there are three areas that are security touching that we definitely aim to improve. One of them is the chaos engineering. We already do have some tests around it where we kill pieces of the Zowe and verify that it's still gonna work when it's deployed in the HA schema. We intend to integrate the agile threat modeling more heavily into the work of each squad. This is something that's at the moment in the process of discussing and preparing how to do it. And we intend to, so we already have some amount of tracing and operational information across the Zowe, but what we are still missing is to make sure that we have one trace for each user doing something across the Zowe in a way that's easily congestible by e.g. OpenTelemetry. The next steps we have around the golden CI badge, some of them we already have, like the developer certificate of origin. This is required by anyone contributing to the Zowe. Some documents around security requirements, we have some, we will get more. Once we have the vulnerability reporters outside of Zowe, we will give them a credit. And we make sure that all the components that we use are in the computer processable way. This is the SPDX format for SBOM and the TPSRs I was showing. Apart from that, some of them, again, already we follow some principles, some cryptographic algorithms. We don't store authentication credentials. And if we do in the CLI, then it's using the mechanisms that are native for the system it's running on. We use the TLS 1.2, 1.3. So, and we will adapt as the new ones are being developed. As I said, for the threat model and trust boundaries, we still have some reserves there, and this is what we intend to improve. We also intend to improve the security reviews by the independent actors. Like, we do security reviews, but they are now mainly internal, so we don't really have like auditable results from external companies that are not involved in any way in Zowe. As for development practices, we already require two-factor authentication to prevent the issue I've talked about with the RC-CO and so on. All the modifications to the source code are reviewed by at least one person. In areas that we consider security sensitive, we actually require two people to review the modification. We used Git for all of the pieces across the Zowe, and we are looking on improvements to our coverage to follow the statements, branches, and the automated regression tests for bugs that are required by this batch. If you want to contact us or tell us around what do you feel or what do you believe that we are not doing well, we are available either on the Zowe Slack channels, so you can join our Slack, and in the Zowe user and Zowe dev, we are trying to answer all of the questions as a community. If you feel that it's security enough and it should be kept private, there is the Zowe security mailing list that goes just to the limited set of personals that are part of the security work group. And most of the things that I was talking about are visible and to be seen within the Zowe community repository. Also, if you don't want to use any of these tools and channels, feel free to reach out directly to me, either via LinkedIn or on the Slack or via email, whatever you feel is good for us. GSE UK is asking me to ask you to submit your session feedback. So please, I would be very happy if you go there and submit the feedback. I'm sorry, right now I see that I don't have the right link there. Instead of NN at the end, there should be one BE. I'm sorry about that, I missed it. Also, if you want to give me more feedback or on how do you feel, or just more information or concerns you have around the Zowe and security, reach out to me directly and I would be very happy about it. And for the last from the GSE, this is an advertisement to become a member of GSE UK. I guess that Jamie can tell more about it if needed. So from my side, this is all. Are there any questions that you are interested in asking? You have a few minutes, not much, but a few.
Thank you, Jacob. Yes, any questions, anybody? You can unmute your line, by the way, if you want to ask Jacob a question directly, or you can post something in the chat.
It's also early in the morning, so it's possible that I make you sleep.
Yeah. First of all, Jacob, I want one of those gold bars. Can you make that happen? They look very nice.
Yeah. Well, it's not up to me, I guess. Yeah, that's for this. For all the imagery that's used, it's under the Creative Commons license, and under the image there is a link to the origin. So if you want to learn more about the authors of them, you can just click on the link and we will get there.
Okay. So no, I mean, there's a few things that stand out to me there. I mean, I love the it seems so well structured and like with security at the heart of it all. That's the, and I don't know if anybody else, you know, sort of agrees with me on that. But throughout your session, you know, that's everything that's done here has got security in sort of the heart of it. And I mean, that's what DevSecOps is all about when all is said and done. But I guess a question to you is that, you know, sort of putting Zowe aside, I just, even mainframe aside, it still feels that like in sort of a lot of disciplines, security is always kind of still this like afterthought, you know.
Yeah.
And you did touch on that, like sort of the retrofitting, you know, after, and that's what, you know, I don't know if anybody else agrees with this. It's always stuck in my mind that it's for a very long time, you know, it's still an afterthought.
Yeah, that's actually whenever we find some issue anywhere, that's why we are trying to find a way how to integrate some solution to the pipelines to make sure that it's not occurring. The latest issue was with the RC core and UA parser. And based on this, we integrated GitHub actions that verify that within the package.json, we have only the specific versions, that the dependencies are at least a week old, so we prevent this type of issues. So it's like, that's exactly what we are doing. So whenever we encounter something that's happening afterwards, or we find out after it, then we figure out a way to automate it and put it early in the process.
Yeah,
so the developers have it always.
Continuous improvement, sort of continuous learning, isn't it? Yeah. Very good. And the other thing I like is what you mentioned about the executive order. I think that's going to be sort of like a real shake-up for the industry, isn't it? These things that, you know, that look, when you sort of read through them, seems like basic things we should all be doing, you know, for sort of secure development and, you know, baking security into everything that we do. And it's yet another thing that I think is, you know, there's kind of no escape from it now. You've got to do these things.
Finally. We will improve as an industry, and I'm really looking forward to it.
Yes, indeed. So, yes, as Jacob said, this is and thank you so much, and a big round of applause to you, and thank you for coming to present us. I really enjoyed it. I have to confess, and I know this is really shameful as a mainframer, I haven't kind of looked too much into to Zowe, so I'm really grateful for me alone, you know, for coming to talk to us about it today. So thank you very much. So yeah, so Jacob's session is 1BE, and please do give him feedback. If you go to the agenda and click on Jacob's session and scroll right down to the bottom, go past the synopsis, you'll see the link down the bottom there. And remember that feedback is important not only for Jacob, but also for GSE, because we want to know what kind of sessions, would you like in one of these sessions at a future meeting, but also remember it counts towards your CPE certificate, for your hours, for your attendance at the conference. And yeah, please don't forget our charity this year to show your appreciation for these sessions. We're now at 74% of our target, by the way, and there's still a few hours to go until the end of the conference. So it is creeping up, and we hopefully will meet our charity target this year. So next we have a break for 30 minutes to 10:30, and then we're moving rooms, by the way, virtual rooms that is. We're going to room 7. So if you look on the agenda and scroll to the right, at 10:30, we've got a session around defending your mainframe against hackers, ransomware, and internal threats, which should be very interesting indeed, and that's with Trevor Eddles. So hopefully you can join us for that. And once again, Jacob, thank you so much. It was a pleasure having you, and we look forward to hearing from you in the future.
Yeah, it was a pleasure presenting, and also looking forward to telling more about the Zowe and the security there.
Indeed. Okay, thanks everybody. Enjoy coffee.
Yeah, thank you.
Thank you. Bye.
Bye. Bye-bye.